So now you can see this and yes. So very good evening. For today we have session on air pollution and air quality index. So before start this air quality index and air pollution, we have to understand about exactly the industrial processes. We must aware about the industrial process means when we need anything to use in houses in then we have means any product even for any purpose. So the product whatever we are using or we have to use, so that product has to be manufactured by the factory, or we can say the in some premises, that is industrial unit, or we can say the manufacturing unit or industrial activity. So here in this industrial activity, you can see the first for means for transformation of product from the raw material, we need some utilities. These utilities in the form of liquid gases, and to produce the energy for transformation of that product. And during this, some gas emissions are there, some liquid emissions are there, some solid emissions are there. Solid like waste, and liquid means the effluent. And also in case of gases, that is they are emitting into the air. So here you can see some snapshots are there, like air emission from the chimney, from stack, during any industrial activity or manufacturing process. So in this one, here you can see this is the industrial activity, manufacturing unit of an distillery unit. And also in this one picture, that is one stack. Stack is exactly what? It is the one that from where the air emission, or we can say the emissions from burning of fuel can be emitted out in the atmosphere. And due to this activity, the global temperature is rising. Uh, not only in India, it is a global temperature, is temperature of the earth has already risen up to 1.5 degrees Celsius from the normal or average. And because this air pollution or air quality index are commonly used in now in EIA also, and our target is to put in environmental impact assessment studies. So briefly we'll discuss about what exactly this EIA, not EIA exactly means where this air pollution is required. So any activity, manufacturing activity, when any type of emission into the air, any type of emission into the water, or any type of solid waste, or any means hazardous or solid waste to be generated from the activity, then environmental impact assessment is required under the EIA notification 2006 or 2020. And this is already under EPA Act, EPA Environment Protection Act. So under this, you can see three systems are there, environment are there, like a physical environment, biological environment, and social environment. And here, the physical environment, and this physical environment, what is this physical environment have? It has water, air, soil, noise and vibration, flora, fauna, socio-economic, environment, health and social, spatial ecosystem. So under this, you can see the air, one important attribute of this physical environment. So biological, like flora and fauna, that is a biological system. Physical and social, that is socio-economic. Okay. So under the physical only, air, water, soil, noise. So under this air, water, soil, noise, one is the air, and under this air, we need to understand what the air pollution, what type of quality index, and nowadays everyone is aware about the air quality index. So this session has been divided into two parts. One is about air pollution, and after that we will discuss about the air quality index. So in this case, as per EPA Act, that is known as Environment Protection Act 1986, environmental studies are required, or you can say the EIA study required when any activity which is listed under this EIA notification 2006 to be, it is mandatory to to take prior permission under EPA Act by following this EIA notification 2006 2020, because 2020 is in a draft stage only, it is not finalized yet. So now we'll understand about the air pollution. Exactly what is the air pollution? See, you can raise your hand if you have any query or anything like any problem in listening, any issue in for understanding. Even sometime I am just means going fast forward, then you can just raise your hand. You can unmute your mic. You can just speak out. Like here, you can see one subject is air pollution. So we have bifurcated this air and pollution. Means we have to understand the first air, what is the air and what is the pollution. Then we can understand the air pollution exactly. So for that purpose, here you can see the our environment is comprised of two environment, that is physical and biological. Of course, three systems are there, three environments are there. That is social. But if we ignore the social, because human is related to social, right? So but in case of physical and biological, so these are system. Here you can see three things are there. So lithosphere, hydrosphere and atmosphere. So in case of lithosphere, that is the air terrestrial ecosystem, and hydrosphere, it is related to aquatic system. Aquatic related to the marine system or surface water bodies related to. Okay, aquatic means the water related. And hydro, of course, hydrogen and the water, it is very related, so it is coming from that only. So hydrosphere. And atmosphere means atmosphere has actually this biology, this physical environment, air, water, soil, noise, whatever we are studying under EIA, and we are putting under chapter 3. And before going to discussion about the air pollution, we have to understand about the earth where we are living. So this earth has three main core, like you can see the inner core, outer core and mantle. So inner core, where this means we can see that have a different type of crust. So in this matter, some matter is solid, some matter is liquid, some matter is of course matter has three state of physical states, or three solid, liquid, gas. So under this crust, they have this the topsoil is of the crust has the fertility, that is known as crop, means agricultural lands are there, and that is topsoil known as, and this topsoil has the fertility. And in case of some means under the outer core or inner core, they have some gases also, they have some liquid like your water, some water bodies are there, some oceans are there. So these are in means this total matter is in the liquid form. And in the gas, that is atmosphere, then in the air only. So related to air is the atmosphere. So we'll discuss about the atmospheric conditions, atmospheric pollution. So air pollution is directly related to atmospheric pollution. So also we'll understand about how this universe has been originated. In this case, here you can see it is, of course, we have number of theories for origin of this universe, for even evolution of the earth. But one theory, that is Big Bang theory, it is, of course, it is not accepted, widely accepted, but it is somewhat, it is proved somewhere. And for that Big Bang theory, the O means the concept has been, of course, accepted, and they won the Nobel Prize also. Here two major theories are there for origination of this universe. Some means some people are believing that this has been created by God in 7 days. So it is the different theory, of course, but of course we can say the intelligent design of the God. That means we can say here it is written that someone made this universe. Someone is the God, of course, which or we can say the nature, which is of course it is dynamic nature, and this dynamic nature has created this universe, and this universe actually made itself, and that is known as random chance, by the random chance. And for this random chance, there are major two theories. Although we have a number more than 100 theories for evolution origin of this universe, but two major theories are there who are widely, or we can say somewhat they are accepted. Like one is the Big Bang theory. It is like explosion of some material, and one is the gradual evolution, that is given by Darwin. So in this case, Darwin explained about the development of the organism from even we can think about the physics, photon and fermions. If you are thinking about many like energy to be created for an for means mass, of course mass is of course it is fixed and it has a volume and it cannot be created and cannot be destroyed, but it can be transformed. If it can be transformed, that means the transformation of energy can be created by two photons. When two photon of any matter can be mixed together, the energy can be created, and this during this energy generation, the transformation of that material can be happen. So this theory, this Big Bang theory is also supporting this photon mixing and energy explosion at one. Bang means immediately explosion of energy and converting into the something like that, that is universe known as. And in case of gradual evolution, like we are developed from our ancestor, and this happened very slowly, and it takes a billion years, more than 13 billion years. So they support by Darwin, who explained about this. So here you can see in this we have planets, and of course this one galaxy in one galaxy. Now here it is many theories are there, number of galaxies are there, and 13 galaxies already reported in this universe. So this universe, like who support like Big Bang theory, and also other theory, Darwin explained about the gradual evolution of the human or any organism. Under this Big Bang theory, you can see this means, as per this Big Bang theory, one is Arno Penzias and Robert Wilson, who created who thought about this Big Bang theory, and also they means won the Nobel Prize for this discovery. In this one, the entire universe was compacted into a tiny ball, and after that some cosmic explosion has been held immediately at a means at once, and immediately this has been created means in a very short time with the matter and energy in all the direction. So this known as universe, and it happened in not means in very long time. It happens between 2 billion 20 means 10 to 20 billion years ago, when cosmic explosion has been held. So this happened means a number of theories are there. We'll not discuss about all those theories, but we'll discuss about the atmospheric conditions. So what is exactly, so here you can see the existence of life on the earth after the development of the organism, either from the photon, either from the any like protein or DNA or RNA. So this it is we know about the sometime we are saying that earth is type of means spherical. No, of course we know the earth is not spherical, it is oblong spheroid, and this has about 42 kilometer spheroid diameter, and earth axis tilted by 23.5 degree. So, and of course everyone knows about the this earth is rotating about the sun, but this is not in circle, it is means elliptical path on over this sun. And about 60% of southern hemisphere is having a water, and only 40% has the land. In means on the northern area, you can see it is the vice versa, like 60% of northern hemisphere is land, and only 40% is the water. So in a whole land in on the planet is covered by the vegetation and desert and this water. So during the first atmospheric, that is we can say helium and hydrogen. To even in case of one theory is supporting also the energy creation in the sun is only the helium and hydrogen. So first atmospheric condition has been developed by hydrogen and helium atoms. So these gases are these are of course hydrogen atom and helium. Helium has two hydrogen. So that means these gases are were probably lost to space early in the Earth history, and due to the gravity, they have a lighter because gases are very light. Of course, they have a high, very less density, so that they can be produced. And also in the second atmosphere, atmospheric condition, they can be produced. It maybe it is the of course it is the theory only. So they may be produced by volcanic eruption. From volcanic eruption, the gases coming out like of course some gases, vapors, CO2, SO2, carbon monoxide, sulfur, and chlorine, nitrogen, hydrogen, ammonia, methane, and many other gases are there. And due to means after cooling down of those vapors, etc., they has been converted into the water, and after that the ocean has been created. A long time of evolution. And during this evolution of atmosphere, because there is some number of gases are there, so this H2O breaks into two, or we can say during the ultraviolet radiation, because sun means during the sun radiation, the ultraviolet radiation is also there. So during the reaction of this ultraviolet radiation promotes the breaking of H2O molecule into the ozone. So here one photosynthesis reaction is also there, because some other organisms are there who are taking oxygen for their photosynthesis. So during this photosynthesis, CO2 plus H2O and sunlight, so they are making some food, that is an organic compound in they are storing into their in fruits or seeds, etc. And during this process of photosynthesis, oxygen also evolve. And another cyanobacteria are BGA, blue green algae, etc. They're also means having this type of process photosynthesis. So during this photosynthesis, oxygen may evolve, and after a long time, so this oxygen about 20.947, or simply we can say a round of 21% by volume, as it is occupied on the earth. And you can see here the number of gases like nitrogen, oxygen, argon, neon, carbon dioxide, helium, methane, krypton, hydrogen, nitrous oxide, and xenon. These are the percentage by volume it is available on earth. So now coming to this point, exactly the definition of air pollution. In June 5, 1972, after that this World Environment Day has been started in Rio de Janeiro in country Brazil. Here many countries are gathered, and also there's some problem related to in between this Sweden and UK. So these countries having losing green forest due to particulate matter, sulfur dioxide, means emission from the power plant, UK power plant. So in this case, they went to international court, and means in that duration, the UNEP, that is United Nations Environment Program, has been started, and as per this UNEP, the definition of air pollution was that is transfer of harmful natural or synthetic, or we can say the transfer of harmful natural and synthetic material into the atmosphere directly or indirectly. They affect the human life. That is known as air pollution. But exactly as per the definition in today's scenario, so you can see here, as per today's scenario means we need to justify the definition, like it means the presence of any air pollutant in outdoor atmosphere of one or more contaminant, or we can say the combination of contaminant, like your dust, fume, gas, mist, odor, smoke, vapor, etc., in such quantity with characteristic and for some duration. in such a way that they are injurious to the human or plant or animal life, or to the property, or unreasonably interfere the comfortable enjoyment of the life and the property, that is known as, or that said to be as air pollution. Means only the condition or any one pollutant is means mixed with the air, that cannot be said as a pollution, air pollution. Only that condition can be considered as air pollution when that means contaminant or air pollutant mixed in the atmospheric condition or outdoor atmospheric condition for some duration that is injurious to the human health, plant life or animal life, or the property like Taj Mahal or any type of which is monuments, etc. That is known as air pollution. And most prevalent type of air pollution, like due to the smog and soot, and these ground level ozone is also making this smog. So particulate matter is also can be made up of tiny particles of chemical or smoke or soil or dust or allergen, etc. They can be carried to the air and they can have means this air pollution. So if we classify the air pollution, then there are two type of classification, two type of pollution. One is the outdoor air pollution and another one indoor air pollution. Indoor means inside our room or inside the living houses, and outdoor pollution means in the atmosphere outside our home, outdoor. It is hence it is named. So outdoor pollution like smoke, particulate matter, PM, acid rain, greenhouse gas, these are the basically the pollutant. And any pollutant, what is the definition of pollutant exactly? Any type of agent or the combination of such agent, including any physical, chemical, biological, or radioactive substance or matter which is emitted into or otherwise the ambient air, that can have high enough concentration, that can harm to the human, that can harm to the animal, that can harm to the vegetation or material, and mainly divided in emission from the identifiable sources and formed in the air by interaction between the pollutant like primary pollutant or secondary pollutant. They can be set as a air pollutant. So major pollutants are suspended particulate matter, CO2, CO, SOx, and NOx. These are the major pollutants, but you can see a number of other. But we'll discuss about the health factor or risk factor due to this particulate matter. Here you can see these are the means pollution factor. First is the air pollution, air water pollution, occupation health, and soil, other chemicals, metal, etc. So in all these four comparative pollutions, you can see the air pollution has high risk factor. It is compared for 10-year data by WHO and also global burden of disease study. And the source we have already provided here. So this was studied by Lancet in 2017. It is published paper. So you can see by air pollution, number of deaths are more than the water, occupational and other chemical pollutions. And here you can see the means some data, the risk ratio in air pollution with others one like for PM 2.5, 10 and ozone and NOx. So here you can see the annual basis and 8 hours basis also. The health outcome is like risk ratio is it is high in case of PM 2.5. That means PM 2.5 is more dangerous to PM 10, and after that PM 1 is more dangerous to 2.5 and 10. And here the mortality rate it is given in different country. So you can see number of due to this air pollution only. And so now we'll discuss about what is exactly this particulate matter. In this particulate matter, you can see the particulate matter when we are means developing, discussing about or thinking about what is the size of this particulate matter. We have it means still now we are considering PM 2.5 and 10 only. So in case if we measure our hair, so the hair diameter is about ranging from 50 to 70 micrometer. And in 70 micrometer, that means you can put 10 particles of PM10 at one hair. Now you can assume how many PM 2.5, and that means the dust particles are some particle having diameter of 2.5 So how many particles will be combined in this? Because in PM10 only one particle, they have four particles of PM2.5. And here you can see the one comparative study, comparative comparison with the sand, fine beach sand. This has the diameter about 90 micrometer. So in this 90 micrometer means a 9 PM10 particle can be stacked together to make one sand beach, one particle of sand. And in case of this, if we are putting 2.5, then how many? About 3 means 36 PM2.5 is required. Okay, so this actually particle matter is the material like dust, smoke, or soot that are directly emitted to the air or result from the transformation of gaseous pollutant. And also these particles coming from the natural sources are like for example volcanic eruptions, and some human activity like burning fossil fuels or incinerating waste or smelting the metals, etc., like we can say the industrial activity. So here you can see major sources one is the pollen, mold spores are there, also house dust, bacteria, any allergens category, viruses, and also cement dust, fly ash, oil smoke, smoke, tobacco smoke, and also soot, some gases, contaminant, etc. These are the major contaminants or we can say the constituents of the particulate matter. And in case of dust, three type of dust may be there, like suspended particles, like suspended atmospheric dust, settling dust, and heavy dust. So here you can see the size of those, like 1 PM1 and PM100. Here you can see the size of these all the dust. 10 micrometer, 1 micrometer, 100 micrometer. So this is a particle means size of PM10 on the basis of scanning microscope. And here you can see this picture was taken in New York by D. Hersey of 2.51. Here you can see this is the scale of 2 micrometer. So this has this is from the filter rating grid. Yeah, and also here you can see PM 2.5 and 1. So 0.1, or we can see the PM1 is more dangerous to PM 2.5 and also than PM10, because PM10 has a higher range, higher diameter, and means the diameter is very less. Then the severity, or we can say the dangerosity is means smaller. The particle are more dangerous. So these are, and also these total suspended particles. In this total suspended particles means includes PM1, PM2.5, PM10, and more than that. So we are means considering when we are considering the dust, then this have all type of suspended particles and the dust. But in case of when we are going for suspended particle like RSPM, respirable particles, then we have to consider 10 PM10 only. So science is important to behavior of this particulate matter in the atmosphere, because smaller particle can fly away from the source, or we can say that they can travel more distance. So particle between 5 to 10 micrometer are removed by physical process in the throat by alveoli. Here you can see this is the size on the basis of size comparison. And particles smaller than 5 micrometer reach to the bronchial tube, where particles of 2.5 micrometer in diameter are smaller are breathed into deepest portion of the lung. Or we can say here you can see means PM1 can reach to deep into the lungs. Means they cannot be breathed out from our lungs. So PM1 is more dangerous. Here the sources, some industrial activity, mobile resource, some sources are there, like some stationary like stack, natural sources, volcanic eruptions, some area source like your petrol pump or something. These are also, and some causes like smoke coming from the wildfire, volcanoes, methane, etc., and dust during the any other natural calamities, and from the anthropogenic activity like power plant or industrial activity and automobile fume, burning wood, and stoves, fireplaces, furnaces, etc. Major effect of this air pollution is disease, are environmental effect like acid rain, eutrophication, haze, wildlife, ozone depletion, crop and forest damage, and finally the global climate change, because temperature is rising due to the rising of this carbon dioxide, or we can say the temperature rising globally. Of course, it is already has 1.5 degrees Celsius. And major impact over the climate system is changing. The pattern of rain, pattern of fall, means the temperature, health, economy, and also it has already on the environment, ecosystem, and also on the forestry and agriculture due to the air pollution. So what are the mitigation measures for air pollution? Basically, first we have to use wisely for all the type of equipment, not for only vehicle. Also we have to use in the houses like refrigeration or all the activity for sustainable development. And some treaties are there, international conventions are there, we have to follow, and not we only, everyone have to follow. Some national guidelines are there, some standards are there, so industry has to follow those standards. So we have to go for recycling 5 hours, reduce, avoid, etc. We have to go for lower combustion of any fossil fuel. We have to go for transboundary emissions. We have to lower down our carbon footprint. We have to lower down the emissions at the source. So by achieving these major goals, we can reduce the air pollution at the source. Now we'll discuss about exactly as per the EIA requirement. In the EIA, we need for air pollution, the meteorological parameter first we need to understand. There are two type of meteorological parameter. One is the primary parameter and second one is the secondary parameter. In this means because your air pollution depending on the meteorological parameters. In case of primary parameter, there are four major primary parameters. One is the wind speed, and second is the temperature, and third is the atmospheric stability. Fourth one is the mixing height. In secondary parameter of this meteorological parameter, so precipitation like rain, humidity, solar radiation, visibility, and terrain condition of that area is also important under this for dispersion of the pollution. So for this we have to understand what type of scale of for this means primary parameter. So first we'll discuss about the scale of meteorological measurement. So under this, meteorological conditions has been divided into three scale. One is the synoptic scale, that is also known as macro scale. Second one is the meso scale, and third is micro scale. So as name suggests, macro means as a longer area, or we can say wider area. Here in this synoptic scale or macro scale, the uniformity of meteorological condition or the meteorological parameter, whatever we have here discussed here, like wind direction, temperature, stability, mixing height, precipitation, humidity, solar radiation, visibility, terrain condition, etc., is of all those conditions in the area is having more than 1,000 kilometers in case of macro scale, and the effect is felt within days to weeks. Means like if rain started from at one place, then that take about 1 week to reach. One example you can take here, that Canada is cold country, but Kenya is warm country, because there is a difference in that area. So those means when uniformity of that meteorological condition, a parameter, is having more time to cover, that is macro scale. In case of meso scale, the uniformity of meteorological parameter for distance over 100 kilometers. So either you can just understand in case of micro scale, meso and macro. In macro is 1,000, in meso is 100, and in case of micro is 1 only. So from 100 and 1,000. So you can immediately differentiate between these three. Micro scale is 1 kilometer, means the parameter is under this 1 kilometer, that is no micro meteorological condition. As it is, and we need to cover in EIA the micro meteorological condition only, not meso or macro. So under this meso scale, the uniformity of meteorological parameter for distance over more than 100 kilometers, and effect felt within hours to days, some days like 24 hours to 36 hours, 48 hours, like that. And in case of due to means these major scale in the meteorological condition due to the land sea breeze, mountain valley winds, migratory high and low pressure winds. During the winter season, North India is cold compared to Southern India. That is one example. And another example you can see in Kuwait in 1992, the soot from burning oil well of Kuwait, the landed in Turkey. So it means immediately they have to cover about 100 kilometer in one two days. And in case of micro scale, here due to the transport of that pollutant, whatever we have discussed, any type of pollutant, and the dispersion of pollutant in that area after 1 kilometer, that is known as micro scale. Our uniformity of meteorological parameter for distance over 1 kilometer only, that is known as micro scale or micro meteorological scale. The effect felt within minutes to hour, means within hour they can feel, we can feel all those conditions. So like smoke from your chimney or smoke from means stack, so severely within the micrometeorological range. So some parameter like wind velocity, we have already discussed, atmospheric temperature, mixing height, some stability classes. So we'll discuss about the stability classes also. Here you can see the layers. We also we must know about this. Some one is a troposphere. This is the Earth surface. So here is the troposphere, and after that pause is there, tropopause, and after that stratosphere, and again one ozone layer is there, and after this ozone layer the mesosphere will come, and after this mesosphere the ionosphere is there, and you can see this troposphere ranging from 0 to 14 kilometer, and after this 18 kilometer up to 90 kilometer, it is up to 50 kilometer, it is the stratosphere, and from 0 to this means after 50 to 90 kilometer it is mesosphere, and from this mesosphere the ionosphere is started. So now we'll discuss about the wind direction and wind speed. So here you can see wind direction. Of course, we know, we must know about this, and we means in EIA studies we are putting this very well as for wind rose diagram. Sometimes we have to put the plume rose. We are just using the wind rose. We'll discuss about the plume rose also. So first we have to understand what is the wind direction and what is the significance of this wind direction, wind speed in our EIA study. Because this wind speed and wind direction is because this wind, due to this wind direction or wind speed, the pollutant may carry out from this source or from your stack to the another area, another place. So the GLC, one concept is ground level concentration, and this ground level concentration of any pollutant like PM or SOx or NOx is depending on your wind direction and wind speed. If because this GLC will fall in only a downwind direction, this will not go in any case in the upwind direction. Why? Because for any moment of that particular matter or any pollutant, the wind speed is required. In calm condition, this will deposit itself on the stack or in nearby the stack or within the premises. So the wind direction is the most important factor, or we can say the meteorological condition of that area. In that four major parameter, wind is important. So the direction and speed of surface will govern the drift and diffusion of air pollutant, which is discharged from your nearby area or from the stack on the ground level. So higher the wind speed, or we can say from the source or near the point of discharge of pollution, more rapidly are pollutant carried away from the stack or from the source. And in this condition, more dilution will be there, or we can say the dilution will of that pollutant in the air will be more. And also the wind direction is generally defined the orientation of wind vector in the horizontal plane. So wind direction for purpose, the direction from which the wind is blowing, and it is measured in degree clockwise from true north. Clockwise means in the clock only, and wind direction of plume or puff in the air quality modeling application when we are running the air model like air mode, cloud, etc. Whatever you are using in AI report for modeling to calculate PLC, that is ground level concentration, and also this wind direction may be measured directly using wind vane. So wind it is the one equipment. Wind speed represents the magnitude of wind vector, and direction represent the orientation of wind vector. We'll discuss about how we can prepare the wind rules diagram, and this can be taken. The data can be collected for wind direction and wind speed using the wind vane. For temperature, it is also most important. The measurement of ambient temperature at single level and the measurement of temperature at different two level is very different, because for comparing between the AI report we are putting the temperature in dry bulb and wet bulb for only these physical parameters, air quality, they are diluting, or how they will dilute during the means operation phase of this, like when your emission will be there, means air emission will be there from the stack, then what type of pollutant will be diluted in the atmosphere. So we have to put the temperature, wind speed, wind direction, humidity, rainfall, etc., so that one can understand what type of micrometeorological conditions are there. So how much dilution may be there in the vicinity. So ambient temperature used in determining the amount of rise experienced by the buoyant plume in the condition created by the environmental surroundings. And this vertical difference is used in calculating plume rise under stable atmospheric condition. And also they can be used in stability parameter like Pascal stability class. And here the humidity of measured in 2 meter consistent with the World Meteorological Organization standard. So we have to compare with the World Meteorological Organization these parameters. First, we have to understand about the atmospheric stability. There are major 6 stability classes, which is drawn by Pascal Gifford. But now we have 7 actually, and after that you can see here A, B, C, D, E, F. These 6 classes of stability classes of atmospheric condition has been drawn or categorized by Pascal Gifford. So first you have to understand this figure. Here the plane X and Y. This is the X axis and this is the Y axis, and this the height of the chimney or the height of the stack is Z axis. LBS, because in when we are going for means concentration, the volume should be there, and for volume we need LBH. So here you can see the L, B and H. So this X is the L, and how this X can be defined. So X is means in the direction where the plume rise is there, like in the downwind direction. And for that purpose only we said that this wind is most important parameter to determine the pollutant concentration and the direction of that pollutant or GLC. So you have to means calculate the GLC on x-axis. Means your GLC at which distance your GLC will be there. So this is the distance in on x-axis only, and this y-axis is the your whole premises of that, and this z is the height of your chimney. So on this basis, the ground level concentration can be calculated using Gaussian plume model. So here you can see this is the wind blowing from this, and this is the wind downwind direction. So under this downwind direction only, the plume center line will be there. You can draw this center line and number of classes are there. It is the only one standard condition. When some means like here you can see say 7 classes are there. By Pascal Gifford, they have classified under six classes. These are atmospheric turbulence, and class A is the most unstable, and class is most stable condition. We can say the calm condition. So here extremely unstable is the A, and you can see the delta T and sigma theta degree is there. So what is the delta T? Delta T is the change in temperature per 100 meter. Change in temperature in degree Celsius per 100 meter. Because if you go from means one place to another place, so some temperature may be changed in either in point some in degree Fahrenheit. Here this is the temperature in degree Celsius, but the exact temperature will not be there, because temperature is governed by some other atmospheric condition or some other factors. So at every 100 meter, temperature will maybe changed either in point 1, point 2, point 3, etc. So this delta T is the change in temperature from one place to another place at every 100 meter, and sigma theta degree means the orientation of wind pattern. So here you can see extremely unstable, like more than 1.9, more than minus 1.9 change in temperature per 100 meter, and moderately unstable B, and slightly unstable C, neutral is D, and slightly unstable stable is E, moderately stable is F, and extremely stable are, we can say, the calm condition, where more than 4 degree temperature is changing at every 100 meter. So extremely stable condition. So under this stability, dry and wet adiabatic pressure due to the atmospheric condition, and these six stability classes can be classified like acceleration is 0, then neutral condition will be created. Acceleration of partial 0 means there is no any type of conditions, and means there is nothing. Calm condition we can say, sorry. In this here you can see the stable condition is not calm, neutral is the calm, and stable condition means calm condition means is calm condition. But the atmospheric stability is depending on all factor, all four and plus 4, that is primary and secondary parameters. So dry adiabatic lapse rate at which a parcel of dry air cools down, and during this decreasing pressure when rising vertically without any energy change. So this the cooling rate will be 0.98 degree per centimeter, means per 100 meter, and where acceleration will be 0, then neutral condition will be created at this D class will be there, or we can say the class number 4 will be there, where acceleration will be 0. Suppose and also here in this case you can see this is the means from unstable to stable condition. Means if you are going from A to G, then you can see the means they are going for stability. From A is high unstable, and to G is the very stable condition in the atmosphere. And about the mixing height actually the height from the ground, or because the height above the earth's surface to which related pollutant will extend, and primarily through the action of atmospheric turbulence, and the surface of the earth start heating after sunrise, or we can say after sunrise in the morning, the earth's surface heat, and if it is just started heating, then what will happen, the convective currents will be there. So this start mixing layer, this form a mixing layer, and the current rise vertically till noon, and after that gradually erode the ground immersion layer that was stabilized during the night time, because in night time temperature will again cool down. So couple of hours after midday, rising current decreases and mixing layer remains steady until sunset. So this layer of air at the ground to the base of inversion layer is called mixing height. in other term, we can say the height from the Earth's surface at which the turbulence or the mixing of that particular pollutant in the air is not more than that. Means at we can say in other term, the distance from the Earth's surface at which point where the turbulence will be created between the atmosphere and this pollutant, and after that the plume rise will be created. And here you can see in the previous one, here in this one. So from you can see this is the x-axis and this is the y-axis, right? And this is z. Z is the exactly one is the height of your chimney, and after that on this z only we can calculate the mixing height. So what is the mixing height for this particular figure? So the mixing height will be this one, because here the turbulence is means started from this one HE at 1.2.3 point, and after this is the stable condition, or we can say after this there is no more height to be attained by this plume. So after this is the highest point to attain this by the plume rise. So that is the highest means highest point. So that distance from this x-axis will it is known as mixing height. So how we can estimate the mixing height from for any particular area? So by using radio sonde or mini sonde, and some soda methods are there also, and otherwise IMD has the mixing height, and we also IMD has developed with the CPCB that one atlas mixing height atlas, like Windrose atlas is there, so mixing height atlas is also there. You can also take exam mixing height from that. Otherwise all the means software which we are using today, like Armored View or Cloud or Envitrans, etc. So they have also inbuilt mixing height for a part some cities. So you can means for the district. So you can use those mixing height automatically by putting the name. Before that, in case of before 2015, we are using manually. We have to put the mixing height as per our assumption, because the mixing height in the mixing height atlas, it is for 30 years, but it is available for year 2000 only, from 1970 to 2000. So we have to assume the some mixing height for particular area, and also in that atlas we have not mixing height for every area. We have sort of some cities only. So now in our software like Armored or Armored View or Cloud, etc. So these all modelers, they have the mixing height inbuilt. So immediately one can put the name of that particular city. So immediately the mixing height will be calculated by the software. So another last parameter is precipitation. It acts twofold cleansing action. Also, this is known as the means diluting factor, because the pollution will be diluted in the rain. Henceforth, only the monsoon means the study, or we can say the monitoring, is not permitted in monsoon season. So this precipitation data are primarily used in wet deposition modeling, and also it is used for consistency checks in data for review and this validation. And also here one factor is the humidity. It represents the amount of moisture in the air, and it variable including like vapor pressure, dew point temperature, specific humidity, absolute humidity, and the relative humidity. Solar radiation. This radiation refers to electromagnetic energy in solar spectrum ranging from 0.1 to 4 micrometer wavelength. And this negative radiation include both solar radiation and terrestrial or long wave radiation. This solar radiation data are used to determine the atmospheric stability, like in case of Pascal's classes, and also for calculating various surface layer parameter like dispersion modeling and daytime or nighttime mixing height, etc. So and also for photochemical reaction. So this solar radiation is used. And last one, the terrain of meteorological condition, this is the area where your project site is to be situated or to be classified. So this area should be classified as urban when more than 50% of land inside the circle of the kilometer around the source can be considered built up with heavily or medium industrial, commercial, or residential unit. Then we have to select as a urban. Otherwise, we have to go for rural area. And in this turn characteristic, because this turn characteristic also is a limiting factor for the pollutant. In case of where a hilly area is there, then pollutant cannot travel more when I mean some hill or some other because these hills or mountains will act as a barrier. So here you can see the analysis after in the last 150 years. These are the development under this wind analysis. In 19, sorry, in 3, you can see this is the diagram. In case having north and south, and it was divided into this means 4 into 4. That is actually 8 directions in 1843 by Lionel. So that is not. And after that, in computer era, now we have a Windrose diagram, and there wind category we can immediately assess wind category, wind blowing from. By default in the computer software, the wind blowing from it is shown. And now after 2007, it was developed by George. So here you can see the plume rose diagram. So this is or we can say plume rose or pollution rose. It is also known as pollution rose exactly. So here plume rose diagram, it is the improved graphical representation, and also it is based on the actual area after 10 kilometers. But so this of course we are considering 10 kilometer radius in also, but this is not related to area. The wind roads have one limitation, that is it is not correlated with the area. But in this plume rose diagram, it is directly related to the actual area. We can say the area in kilometer. So under this plume rose, immediately one can identify how much percent of wind or which type of wind speed is there in that particular area, and what type of duration and what type of distance from your source. So this is more important and improved graphical representation of this plume rose. Some regulations are there, like Explosive Act in Indian Boiler Act 1923, Factory Act, Atomic Energy Act, and Air Prevention of Pollution Control Act 1991. Some rules are there, amendments are there in 1983 and 1987. And Factory Act also in 1987, it is amended. And after Gas Cylinder Rule 2004, and one National Ambient Air Quality Standards are there. We are following 2009. So these are actually regulations related to air. Some models are there. You can see these are air models related to the graphical representation of your concentration, or we can say the resultant concentration, or we can say in other word, that is the actual calculation of resultant concentration. So here meteorological model, 6 type of models are there: emission model, source dispersion model, receptor model, and chemical model. And these models depending on chemical transformation, pollutant transport, equilibrium between the particle and gases, and also it is depending on the vertical mixing and temporal and spatial emission rate from the source or from the stack. So now we'll discuss about the wind, how we can measure the wind, how we can make the wind rose diagram. So for measuring the wind, you can use the wind vane, and also anemometers are there. So speed can be measured using anemometer. Direction can be measured by wind vane, and height of measurement is minimum 10 meter from the grounds or from the surface. So for that purpose only, we have to put our this anemometer on the means overhead of the building. Like some open space should be there, flat surface should be there, and there should be no obstruction. And windrows is the information laden view of how wind speed and direction are typically distributed in particular area. and this is the circular format exactly, from where we can see some spokes are there, and each spoke around the circle is related to the frequency of time that the wind blows from a particular direction, and the concentric circle represents the different frequency emanating from zero at the center to increasing frequency at the outer circle. Here you can see this is the one wind set vane of the anemometer, and here this is the suppose one affected area. So wind can be blowing from any direction, of course. So on the means wind rows, one can immediately predict from which direction the wind is to be originated, or wind is blowing from which direction, and how much speed of that particular area, means which is the highest speed in which area, or in which the date. If even we have to we can check the date also from this. And here you can see you can download this software free of cost from the Lake Environmental. We have provided the link. So after clicking on this link, you can download freeware. It is freeware WR Plot. So after downloading, you have to install, run as that you can install by using your, by accepting the license agreement. Here the screenshots of there to install, and you need to fill username and organization, or if you are using it for personal use, you can put your name, and after that you have to click next, and after that immediately you will just install by clicking next and next, and after you have to accept the license agreement, and after finishing you will see your WR Plot has been installed on your laptop or desktop, and after that you will able to run this WR Plot software for plotting the wind rows diagram. So how you can create the wind rows? Here you can see, for making wind rows or plotting the wind rows, we need the 3-month or 1-month data. In term of this is this should be hourly data. This is not required. Sometimes suppose if you have monthly, means daily data, then you can put the daily. This can accept any data. Means hourly data is of course very much ethical. You can put hourly data if you have. Otherwise, you can put daily data. So here you can see the hourly data has been given to this for direction, wind speed, and precipitation. Precipitation is not required. You have to put data. If you are going for wind rows only, then you have to put direction and wind speed only. Precipitation, cloud cover, etc., even temperature, etc., is not required for plotting the wind rows. And after this, you have to import this Excel sheet. You have to provide this data in Excel sheet only. And after this, you have to import this Excel sheet into this by clicking here. You can see add file, and here tools are there. Import from Excel. If you have Excel sheet, if you have another type of format, then you can also browse all those data. Otherwise, you have to import from the Excel, and after that you have to convert into this this Excel sheet should be converted into the SAM file, and you can see this your data whatever you have here you have given, you have imported, so it can be seen over this software. Here you can see the year, month, day, hour, wind direction, wind speed, and precipitation. But because here we have already given the precipitation 000, that is rainfall. So after viewing that your data is correct, then you have to convert the SAM file, and after that immediately you can run for wind classes and stability classes also. Here you can see this bar, this address bar is there. The SAM file will be generated, and after that you have to go for your wind classes. So immediately you will click on this wind rows. Here it is wind rows. Then you will see this type of wind rows. So in this wind rows, immediately you can clear. This is the highest vector. So one can predict the wind direction will be from northwest to southeast. The downwind direction will be southeast. Okay, in this diagram, because this diagram shows the wind blowing from, here it is already written by default. This has the blowing from. So immediately you can convert your data, your Excel sheet or your raw data into the graphical representation using the WR Plot software. So now we'll discuss about how we can put this framework, or how we can decide the network, sampling network. For sampling network, we have to understand the site, your site, how which type of site is there, like point source, line source, area source, from your existing inventory. So if we do not have, then you have to collect the secondary data, and after collecting the secondary data, we have to check for quality control, and then we have to go for emission characterization, point or area source, whatever we have, line source, etc. And after that, if we have decided that area source, line source, or means point source, if there is a point source, immediately point source means the stack emission. So here you can see some examples. Point source like combustion material are non-combustion sources. In case of combustion sources, it has been classified under two: point and non-point. So you can see the cast iron furnace, fuel and oil combustion, incinerator, diesel generator, kerosene generator, petrol refining, power plant, power coal-based power plant, natural gas power plant, brick and clay product, or coal combustion, etc., are the point source under combustion sources. In case of combustion source but non-point, like LPG, home, wood, kerosene stove, agriculture waste burning, coal stove, cow dung burning, bagasse burning, etc., solid waste burning, refuse combustion, etc., these are known as non-point sources. And here under non-combustion point source, like petroleum refinery, fertilizer plant, hot mix asphalt packaging, glass manufacturing, iron steel production, cast iron, gray iron foundry, carbon black, paint varnish, etc. In case of non-point source like paved road, unpaved road, soil dust, asphalt paving operation, construction work, or anything from where the residual dust emission or something is there, then non-points under non-commercial source will be identified. So for this air quality monitoring network, we need to go for monitoring three as per as per your standard chart, 3 months or 1 season, or sometime we need for 30 days. And sampling frequency will be 8 hours or 24 hours. It is depending on your TAR or specific research activity. And also for mixing the monitoring height, it should be more than 3 to 5 meter above the ground. There should be no obstruction or no barrier where we need to install our FDS RDS. And for PM 2.5 and 10 being focused on the study, their collected masses were subject to further analysis, like your EC or major trace elements, conductivity, sulfur dioxide or nitrogen dioxide, trioxide, SOx, NOx, etc. This should be designed considering all those receptor modeling. Means we have to fix the purpose or objective, what a parameter are to be monitored for modeling or for our requirement. In general, PM 2.5 monitoring and related analysis had limitations of number of days of sampling, besides days of sampling were not concurrent or regular. So we have to keep in mind that we have to take sample separately for PM 2.5 and separately for PM 2.10, because under 10 this is already there 2.5, but in case of 2.5 this the other particle matter like more than 2.5 should not be there. So we have to install separately FDS and RDS, and for SOx and NOx we have to put separate means. Here you can see one example of boiler. Some 1.5 TPH boiler is there. So they are using wood, means bagasse. Sometimes they are using firewood. So this is firewood. Here they are putting the firewood into this furnace, and after that they means in the side of this furnace they have a boiler of 1.25 TPH to generate the steam for their purpose. And here one example is for sampling. Here you can see they have means placed one FDS. This is combo sampler, of course. And also if you are not identifying, then you have to put this type of windrose diagram for exactly, because you can see this flag is also representation of one the downwind direction, and also from this windrose diagram immediately one can predict the downwind direction is from this point to this point. You can see the cursor from this point to this point. And some criteria are there, like first we have to decide the predominant wind direction, then we have to also decide the topography. We have to understand topography and terrain of that area, regional synoptic scale, like macro scale of that area, then densely populated area if there, that is known as receptor points, and location of surrounding industries if there, then you have to avoid, because if you will put in surrounding area, I mean, nearby the stack, then immediately this will it means affect your constitution or result. So the facility also we have to look for facility for ambient air monitoring, where we can put our sampler FDS, RDS, whatever we have. And also we have to avoid the proximity of road construction activity or any other activity, whatever the temporary or permanent, etc., which can lead some means they can affect our result, they can affect our conclusion. So, and also we have to look into the availability of manpower, electricity, approach route, study structure, production of sample, because we will put this sample for 3 months. So we have to keep all those points in mind. And here you can see the example how we can design the network by using the windrows diagram. So if you are going for means any specific month, then you can refer that particular month of windrows diagram of previous year, because suppose you are going for October month of 2020, then we cannot we should not have the windrows of 2020. So we can refer the windrows of October month of 2019, and after that referring we can decide the predominant wind direction, downwind direction. And after that we can design the network. And if you have the plume roads, as I said in the previous slide, that there is a improved version or decision making, that is plume roads, because this is also with the this your kilometer square with the area. So in that means if you have the wind roads, then you can decide on that. Otherwise you can take decision on the basis of plume roads. Here you can see one example. We have like your project side, the source, and then you have to go for downwind direction. You can see here the 3 samples has been collected from downwind, and out of which 2 are the from only downwind direction, and crosswind direction, upwind direction. Crosswind is down or up. One is either side of and another is one side. So these are the crosswind. Then you have to go for at least one in upwind direction to compare in operation phase that it was created by your operation or other operations. And also for, and here you can see the result of the air pollution. In means EI report, we cannot put raw data. We have to put the process data only. Here you can see the minimum percentile, 90th percentile, maximum, and average. So we need to run the GLC on basis of 90th percentile only, not minimum, not average, max, because max is for a short period of time, but 90th percentile is for 90th time of interval. So we have to put, we have to calculate, and we have to interpret the data. We have to compare the data with the data of GLC with 90th percentile only. And also we have to calculate the accidents factor when we have air quality, this type of air quality we have. Now we can calculate the accidents factor. For calculation of accidents factor, we have to calculate, here you can see the observed annual mean concentration. Here you can put not only annual, you can put your average 3-month mean value for 3 months for rapid EIA. For comprehensive EIA, you have to put annual mean concentration of pollutant divided by the annual standard of respective pollutant. Like if you are going for PM, then you can put 100, whatever you have. And then if you are going for SOx, NOx, as per respective, you have to put. And after calculating, if you are having accident factor more than 1.5, because this is the factor only, that means you are divided by that same unit divided by the unit. That means there is no unit. So this is the ratio only. And this ratio or factor, if this ratio accident factor is more than 1.5, that means your area is critically polluted. And if you are means getting more in between 1 to 1.5, that means your area is high polluted. And it is less than means in between 0.5 to 1, that is moderate pollution is there. If this accident factor EF is less than 0.5, there is low pollution. So you have to calculate this accident factor, and after that you can predict Exactly. Here are some monitoring protocols for PM SOx NOx, PM 2.5, carbon monoxide, VOC, etc. By which means like equipments are there, sampling periods as per your requirement, sampling frequency as per your requirement. This can be set as per the standard TOR. Otherwise, if you are going for any research purpose, then you can set as per the requirement. Like if you are going for 1 month, then you can collect for 20 to 30 day data in continuous. Some monitoring methods are there. It is already well known. Of course, if you are working in the same field, then you are aware. And also, it is available as per IS standards. So, like SPM is for gravimetric method. RSPM, of course, this is also high volume with the cyclones. So, and SOx and NOx, these are EPM method. And CO is arsenide method, and SC is NDIR technique. For lead, you can use some gas chromatographic method, and ozone are some other metals. Lead or any other metals can be used, means can be monitored by WS and also network. You have to select as per your requirement. Like in case of EIA, 8 samples are required. Otherwise, in case of research purpose, it can be defined by the population. So here you can see some pollutants, or we can say the pollutant parameters like thermopar. So SOx, NOx, PM10 is required. These are the mandatory in EIA. In case of oil refinery, then PM, SOx, NOx, ozone, benzene, and nickel is also. Ozone, benzene, nickel is means apart from all those four regular parameter. Four regular parameter PM, SOx, NOx. PM is PM10 and 2.5. Okay, and in case of steel plant, apart from these regular parameter, benzopyrene is required. Pharmaceutical, of course, VOC and benzene is also required. Pesticide, again, benzene and VOC is required. Cement plant, nickel is required apart from the regular. And distillery, sugar, these are the regular, only PM, SOx, NOx. These are the steps. 8 steps are there for monitoring. First, we have to obtain the meteorological data for nearby IMD station, Indian meteorological data. So under this, you have after getting this meteorological data, micrometeorological data like wind rules, we have to immediately put data in Excel sheet, and then we have to import on WR plot or some other software which we have, and after that we have to construct the wind rules diagram. Then we have to select the station upwind downwind as per our wind rules diagram, and after that we have to select the number of station, either means 10 to 8 as whatever requirement. If we are going for research purpose, then it is depending on the population, multiple of 3. And also this can be referred in the standard TOR. As per standard TOR, 8 numbers is required. And station can be fixed nearby the receptor or habitation, and also you can fix your station nearby some other receptor like ecological sensitive area. And this is also depending on the expected emission from the project. And frequency can be as per your standard TOR, CPCB, or as per the air quality standard. And some specific parameters required as per the specific sector. Like if you are going for oil refinery, then benzopyrene, nickel, etc. is to be monitored in the air. And here are the National Ambient Air Quality Standards as per 2019. It was released, means revised on 18th November 2019. So here you can see the annual and 24 hours data has been provided. So it is for two. One is for industrial, residential, rural area, and another for the ecological sensitive area. And these ecological sensitive area should be notified by the central government are under the Wildlife Protection Act 1972. Also, the method is also given, means sulfur dioxide can be measured by improved West and Geiger method or ultraviolet fluorescence method. So this is already provided under this CPCB standard, or means ambient standards. Will share the standard also. And here you can see these all 12 parameter under this air quality standard. 12 parameters are there, and we have already discussed about these site specific data. These are the macro meteorological data like wind speed, wind direction, dry bulb temperature, wet bulb temperature, relative humidity, rainfall, solar radiation, and cloud cover is required. And of course, we have to put the wind direction, wind speed under which this wind rules diagram. And then now we'll discuss about the air quality index. Exactly what is this? Air quality index is defined as an overall scheme that transforms the weighted value of individual air pollution related parameter into a single number, or we can set of number. It is very means familiar. Everyone nowadays everyone is aware about this air quality index, and it is most popular index out of five, not five only, 10 indices are there. This comes under environmental indices, and environmental indices are like fertility index, soil fertility index, water quality index, noise quality index, ecological quality index. Many indexes are there, indices are there. Out of this, air quality index is the most popular among people now in India, and not in India, in whole world. And here you can see this air quality index used by the government agency to communicate to the public how polluted the air currently is, how polluted it is forecasted, means tomorrow. Public health risk increase as the AQI rises. So different countries have their own air quality indices, and in here in India we have a different type of set to calculate by 8 parameter, and under this we need at least 3 parameter to put once. It is proposed that continuous air quality station AQI is to be reported real time basis. So CPCB has started, and in every city means specific our industrial area, they have a sensor, they have this facility for air quality index. So immediately one can see real time data for air quality index. And this air quality index was in we can say this has some feature, because this has one figure, so one can immediately understand this figure is dangerous or not, because this comes with a color code also, and color can be easily understood by all the public, even laymen. And this means technical study on AQI was done by IIT Kanpur, and also one means CSE also involved in this preparation of AQI. So this AQI here you can see 8 parameters: PM10, PM2.5, SOx, CO, ozone, ammonia, and lead. These are for short term, like 24 hourly average data. On the basis of this standard has been prescribed. The formula it is given here. So under this formula, it is it seems too typical to calculate the air quality index, but it means the calculator is there. Means immediately you have to put the concentration of PM 2.5 or CO, etc. Means minimum 3 parameters is required out of 8 parameter to calculate the air quality index. Otherwise, if you have 8 parameter, then you can get the air quality index. Of course, when we have don't have the means all parameter, then we have to minimum 3 parameter. Here you can see this is the exactly the color with color code from 0 to 50. This is the means in color, it will come as green, and this air quality is satisfactory. There is no risk, we can say. Under yellow, that is from 51 to 100, air quality is acceptable. However, there may be risk for some people. And in case of orange, that is unhealthy for sensitive group. And here you can see 101 to 150. So some members are sensitive group, may have some may experience health effect, so that can be taken care. And in case of 150 to 200, this is unhealthy for everyone. And 201 to 300, this is very unhealthy. So the risk of health effect is increased for everyone again. And more than 300 up to 500 or something, this is more hazardous, and health warning of emergency conditions should be there. So now you can see the CPCB has developed one Android app also. If you are using Android phone or some other phone, then immediately you can download from one. We have provided the link also, you can see here. So after clicking this link, immediately you can download. You can install in your means mobile phone, and you can see the air quality index in whole India at any city with real time data. And also this it means you can visualize of any city, particular, like here you can see the example of Gujarat, Vapi. You have to put the state name and city, and then you have to select your station. The date and time will automatically come, whatever the data it is there. So you can see here the real time data of this today only, 8th July at 5 p.m. of GIDC Vapi of GP. This is provided by GPCB. So means you can check the real time data of air quality index by CPCB. It is provided by. There are number of apps are there, like Ayurveda is also there, but the authentic data to be provided by this CPCB only. So you can use this app. Otherwise, you can use this link for web portal. And not only this, here you can see again, this is CPCB, another link for Delhi area, NCR area. It is separately provided. So because in this area, NCR area, it is always on the risk due to this air quality index. It is more than 400, 500. So here you can check. And also not only for India, you can check for whole world. So here you can see the link has been provided. You can check the real-time air quality index on other countries also. By clicking, by observing here, you can see the numbers it is visualizing here. So by clicking on this link, immediately you can go to any country where the stations are working. They have, because every country has their on working on calculation, but you can visualize the air quality index in different country also. And now I will show the air quality index calculator. Here we have shown some links are there. Immediately you can download some reports are there on air quality index, and all other links whatever we have shown here. So you can download the air quality index in India, in NCR for your city. Here how we can calculate exactly by putting three parameters. Can you see this, right? So here you can see, like, you have to put the station name, city name, and then your state. Now after that you can put also the time, means time and date. And after that, here you can see I am just putting here it is 121, the air quality index is 140. Now I am putting this is 50, and now I am it is 57, right? Now I am means going for 0 for PM 2.5, and NOx is also 0, and this is also 0, and this is also 0. So now you can see this what this shows. This shows that at least 3 inputs are required. As I said, for air quality index, you need to put 3 parameters at least out of 8 parameters. So here I am putting PM 2.5 is again, it is suppose it is 25, and SOx is suppose 12. So now you can see the air quality index is 50. So you cannot see means here PM is 10, PM 10 is 50, then AQI is 50. No, it is based on the sub quality, sub index. So when PM 2.5 is 25, the sub index is 42. But in case of PM 10, the sub index is only 50. So higher sub index is 50. So now it is air quality index is only 50. Now I am exceeding this PM 2.5. Now I am putting 50. So you can see this PM 2.5 is 50. So sub index is 83. Now air quality index is 83. This is means for main parameter, concentration of main parameter. Then this will calculate the sub index on the formula whatever we have shown in the previous slide. So on that basis, this can immediately calculate by putting those formula. Here you can see the formula, it is given here, and immediately this will give rise gives the data. Now I am just putting this as a 92. So now you can see this air quality index is 92, but now I am just in decreasing again. This is suppose this is 45. It will not change because the sub index is 92. Maximum sub index is 92. Now I am putting another parameter like NH3 is 12, ozone is suppose 2, and CO is 4, and NOx is 4 suppose. Then you can see the color has been changed. Now again I am putting ozone as 19, and ammonia is 25, and CO is 20, and NOx is there 25. So you can see the color has been already changed when your CO has been changed, because CO 20 has sub index 318. So means even your PM has not been changed, but your CO has been changed due to the carbon monoxide, because sub index of carbon monoxide is 318. Then immediately AQI will be changed. Now I am putting this CO as 50. So now you can see immediately the color again. You have here the AQI is 494. I am putting this as a 60. So again the color has been, this has been changed, and here you can see the 788, and now I am putting as 120. So you can see 906. If we put 250, then you can see 1671. Means as per input data, this will calculate immediately, right? So and also we have some provided all the means link. You can download some report by this report is prepared by CPCB. You can download for more detail of AQI, and some parameter already shown in the previous slide, that you can check real-time data for India as well as for other countries, and also you can check for your city in the vicinity where the sensor has been already installed. Okay. Okay, thank you very much. You can ask your question by unmuting yeah, you can unmute yourself and you can ask the questions. You can yeah, now you can unmute yourself and you can ask the questions. If you have any question related to this, then you can immediately ask the question on this AQI, on this air pollution, and also we'll share the means certificate very soon, today only, and study material has been already sent on your email, so you can check the study material that has been delivered on your email. Otherwise, you can just write us. We'll share again if not received. You can unmute yourself. Yeah, Dr. Krishna Kumar Sinha has unmute. If you have any question, then you speak for your question. Otherwise, you can type in the chat box also. One voice. Okay. Okay. Very nice. So it means some, because we are using this first time. So I'm just seeing your responses during that time. Now the responses are visible. Very nice. So you can you can type in the question box for your question, for your response also. We'll share the details with feedback form also, so that you can yeah, you can provide the feedback also. So now I am ending this session. You can ask the question on WhatsApp also. I am sharing here the number. It's 9909968953. Another one is 9450501471. So by on this number you can ask the question, and otherwise you can send by email related to this session. Okay. Thank you very much for this time, and now I am ending this session. Thank you very much.